Jai Hind everyone. This is Dr. Naresh Kumar from Akgec College, Ghaziabad. Welcome to the class of Optical Communication. In this video lecture, basically we will discuss eye diagram with eye pattern features. So first of all, what are the main contents for this lecture? As clear from the topic heading, in this lecture we will discuss eye diagram, also known as the eye pattern. Next we will study how we can generate this eye diagram, and then we will study what are the various eye pattern features, or how we can say that what will be the performance of a communication system just by simply analyzing the eye diagram for that communication system. So first of all, what is an eye diagram or eye pattern? Basically, in any communication system, we need to analyze its performance. Generally, the performance of communication system may be analyzed, for example, in terms of bit error rate, may be analyzed in terms of probability of error. Like this, we can use any parameter for the analysis of the performance of communication system. But all these are mathematical tools or mathematical parameters. So we need some another method by which we can analyze the performance of a communication system. One such method is eye diagram or eye pattern, known as eye diagram or eye pattern. So basically, this eye diagram or eye pattern is a graphical method for analyzing the performance of wired communication system. Okay, that means if we have to analyze the performance of a wired communication system, that can be done using a graphical method. That graphical method is eye diagram or eye pattern. So basically, why we are calling this as eye diagram? What is the name reason for the calling it as an eye diagram? Basically, as we have studied, the eye diagram is a graphical method. So in this, the graph generated is similar to human eye. Okay, this pattern or graph generated for the wired communication system is of the shape of the human eye. That's why this pattern is known as the eye pattern or eye diagram. As we can see, when the human eye gets opened, we get clear vision and the visibility is very clear. When the eye is closed, the vision gets blurred or the vision is not clear. So in the similar way, we can analyze the performance of wired communication system by simply analyzing the eye diagram or eye pattern. For example, more is the opening of the eye pattern, the distortion is less, or we can say that the performance of communication system is better. And reverse, when the eye diagram is closed or the eye shape is closed, we can say that there is distortion, or we can say that the performance of the communication system is not so good. So we can simply analyze the performance of communication system, especially the wired communication system, using the eye diagram or eye pattern, and this is called as eye diagram or eye pattern because of similarity in the shape with the human eye, or its performance comparison with the human eye. Now next is how we can generate this eye diagram or eye pattern. Basically, as discussed, this eye diagram or eye pattern is generally used for wired communication system. Okay, so any wired communication system that needs to be analyzed for the performance, for that we can generate this eye diagram or eye pattern by simply connecting this wired communication system signal over the standard BER test equipment. Standard BER test equipment. Okay, so the system is for which the performance is to be analyzed, or we can say that any communication system which is under test that is connected with the standard BER test equipment, and on the display or at the output, on the display screen or at the output, what we get is simply the called as eye diagram. Okay, so the eye diagram can be simply obtained by connecting the system under test with a standard BER test equipment, and at the output of or display of the standard BER test equipment we will see the eye diagram or eye pattern. This is the basic equipment shown as used for the generation of eye diagram or eye pattern. Next is eye pattern features. As discussed, by simply analyzing the eye diagram or eye pattern generated, we can comment about the performance of the communication system. For example, it is about the wired communication system. So, here the wired communication system can be, for example, the optical communication system. Optical communication system is also a wired communication system. So, its performance can be analyzed using the eye diagram. So, by simply analyzing the eye diagram, we can comment on the performance of the optical communication system. So, what are the various features of the eye diagram and what they tell about the performance of the communication system? That is known as the eye diagram or eye pattern features. So, from the eye diagram we will study a particular feature, and that particular eye diagram pattern feature is explaining what about the performance of the communication system, that we are going to study in this. This is the one eye diagram. So, in this eye diagram, there are certain points or certain eye features. For example, this feature, zero crossing. Okay. So, this eye pattern feature will explain some performance of system. Okay. So, in this eye diagram or eye pattern, there are certain features, and those features can be translated to comment about the performance of that particular communication system. So, that is the pattern features or eye pattern features. For example, this is the first feature known as zero crossing. Okay. So, this feature zero crossing, basically this tells us about the threshold value, threshold at zero crossing. Okay. So, simply by analyzing this zero crossing or threshold at zero crossing, we can analyze about the threshold value. We have studied that the threshold value should be optimum. It should be neither too high, it should not be too low. So, what is the threshold value above the 0 point or starting point? We can comment about the threshold value from this zero crossing. As we have told, eye diagram is used for analyzing the performance. If the eye opening is more, the performance is better. If the eye is closed, then we will say that the performance is not so good or distortion is there. So, simply by analyzing the eye opening feature, we can also comment about the performance. If eye is opened, then the performance is good. If eye is not opened or eye is closed, then the performance is not so good. Another feature that is used here is eye jitter. Okay, this time gap. Okay, at basically this eye diagram is, we have studied, this eye diagram is a graph or graphical technique. So this graph is in time domain, is taken in time domain. We know that there are two domains, time domain and frequency domain. This eye diagram or eye pattern feature is generally in the time domain. So in this we have the time. So here this eye jitter basically is time delta t. So from this eye jitter we can analyze about the phase distortion or phase margin of the system. So this phase margin or phase distortion can be calculated as delta t by TB into 100, where this TB is known at the bit duration. So in this way we can have various eye features, eye pattern features, and that can be used for analyzing the performance of the wired communication system, for example the optical communication system. Another eye pattern feature is, for example, let's say this width of the eye. Okay, this width of the eye tells us about the time interval, or this is the sampling time range. Sampling time range. This is the time interval over which the signal can be sampled without ISI. Without ISI, that is inter-symbol interference. Another feature is, for example, is this eye height. Eye height. We know that from this eye opening condition, if eye opening is more, the performance is better. If eye opening is less, then the performance is not so good. So whenever the width and height of the eye are more, that means eye opening is better. And if width and height of the eye are less, then we can say that the eye opening is not so good. So that can be also used for the performance analysis of the wired communication system. So the importance of width was, this is the range over which signal can be sampled without ISI. But in this entire range, what is the best sampling time? So the best sampling time is when the height is maximum. So height tells us about the best time to sample. Okay. So in this way we can calculate various features. Another feature that we can also calculate from this eye diagram is about the rise time and fall time. Rise time and fall time. We know that rise time and fall time gives us a measure about the speed of the system. Okay, the system rise time should be fast and fall time should also be fast. Then we can say that the system speed is high, so time should be less. So the rise time is basically time required for reaching the signal level from 20% to 80%, and fall time is reaching from 80% to 20%. So if rise time is sharp, the speed is high, or we can say that rising time is less, the speed is high. So we can also comment about the rise time and fall time from the this eye diagram or eye pattern. From this we can also calculate about the noise margin of the system. Or noise handling capability of the system can also be analyzed. This above threshold, there can be two voltages, one is V1, another is maximum voltage V2. So this V1 by V2 into 100, this is also the noise margin of the system. Another eye diagram or eye pattern feature is, we can also comment about this alignment or this slope of this eye diagram. Slope of eye diagram. We can see that as the slope becomes more and more horizontal, okay, as the slope becomes more and more horizontal, the eye opening is there, and as this slope becomes like this, eye gets closed, so the performance gets decreased. So from this slope of the eye diagram, we can comment about the sensitivity of the timing errors. We can comment about the sensitivity towards the timing error. So as the slope becomes more and more horizontal, the sensitivity towards the timing error or error related to synchronization gets increased, because the eye starts getting closed. And whenever this slope becomes more and more vertical, then the eye opening is more, and if eye opening is more, then the performance of the system gets improved. So we can also comment about the performance of wired communication system in terms of sensitivity towards the timing error, in terms of the eye diagram pattern feature known as the slope of the eye. Another feature that can be used, basically whether the eye diagram is symmetrical or not. Symmetrical or non-symmetrical. Basically, if the eye diagram or eye pattern is uniformly distributed, it is symmetrical in nature, then the system is basically a linear system. And if the eye diagram is non-symmetrical or not properly aligned, then we can say that the system is basically a non-linear system. So simply by analyzing the eye diagram, we can also comment about the linearity and non-linearity of the system. So in this way we can analyze the eye diagram for the performance of the communication system. This is the simplified form. As we have discussed, we will have a eye diagram or eye pattern feature, then there is significance of that particular feature. Okay, so previous was the eye diagram, and this is the simplified form of that diagram which explains the significance of the eye pattern feature, particular eye pattern or feature. For example, as we have discussed previously, this threshold, this is the zero crossing. Zero crossing is telling us about the threshold. Then we have studied the eye jitter, that is telling out the distortion at zero crossing, phase distortion. Then we have width of the eye, as discussed previously. Width of the eye tells us about the time interval over which the signal can be sampled without ISI. Now the height of the eye, as explained previously, tells us the best sampling time in which the signal can be sampled without inter-symbol interference. Another that we can calculate is noise margin by calculating the V1 and V2. Then another feature we were discussing as the slope of the eye. Slope of the eye is telling us about the sensitivity towards the timing error or synchronization errors. So these are the various features that can be used for analyzing the performance of the communication system. These features have been explained here, like height of the eye opening. It is telling us the best time interval in which the signal can be sampled. Noise margin, as discussed, there will be two voltages, V1 minimum voltage, maximum V2 into 100. So we can also comment about the noise margin of the system in terms of eye diagram. Then the rate at which the eye gets closed, that is the slope. We are talking about slope. Slope is explaining about the possibility of timing error. Timing error increases as the slope becomes more and more horizontal. Another example that we have discussed was another feature, timing jitter, also known as the eye jitter. As discussed, this explains the phase distortion, and phase distortion is given by this formula, delta t by TB into 100, where this delta t is time duration in terms of eye diagram eye jitter, and TB is bit duration depending upon the bit rate or data rate multiplied by the 100. Another feature that we have discussed is we can also comment about the rise time and fall time of the system. If rise time is less, we can say that system has speed, and if rise time or fall time is more, then we will say that the speed is slow. We can also comment about the linearity and non-linearity of the system. As discussed, if the eye pattern is symmetrical, then the system is linear, and if the eye pattern is asymmetrical in nature, then we will say that the system is non-linear. Okay. So in this way, we can comment or analyze the performance of wired communication system, for example, optical communication system, using the eye diagram or eye pattern, which is simply a graph obtained in the time domain when the system under test is connected with the standard BER test equipment, and on the display of that device we can have the eye diagram or eye pattern, and this is called as eye diagram because of similarity with the shape in human eye or functionality with the human eye. So that's all for this lecture. Thank you everyone. This is the reference. Jai Hind.